Welcome back at C-Square. In this lesson we will talk about algebraic and geometric proofs, but we're going to start with this algebraic property. These are used also in geometry. So let's see this property of equality, how are called. We have here the first one, the addition property. If A equals B, and then I add the same quantity C on the left side and the right side of this algebraic equation, algebraic expression A equals B, then the equality stays. This is the addition property. Subtraction property is the same. If A equals B and then I subtract the same quantity on left and right side, the equality stays. Multiplication property, if A equals B and then I multiply left side and right side by the same quantity C, then the equality is still okay. Division property, the same story. If A equals B and then we divide by the same quantity C, then the equality stays. Then another property that you will hear it a lot, especially in geometry, is this one, the reflexive property. A equals with itself, A. Symmetric property, another property that you're going to hear also in geometry. If A equals B, then B equals A. Then we have what is called transitive property. If A equals B and B equals C, you notice the same B here, then A has to be equal with C. This is called, as I said, the transitive property. And the substitution property, the last one on this slide, says if A equals B, then you can use B and replace A in any other expression you need. One more property that I'm pretty sure you hear about in algebra classes is the distributive property. And you see here, if we have A times the quantity B plus C equals AB plus AC, and very similar for subtraction, it does work also. So now let's see how we can use this property I named to justify going from the first statement, in this case from this one, to the second one, to this one. What kind of property I can use to go from the first statement to the second one. And this one is a little bit tricky. Why? Because look at here. I'm going to show you what in fact I'm going to do here. I'm going to factor out an x on the first two guys. And I have then 3 plus 1. And then I close the parentheses, plus 7 equals 23. And 3 plus 1 is 4. 4x plus 7 equals 23. So you see here, in order to go from the first statement to the second one, I factor out. In fact, I use the distributive property backwards. So the property that I use here is distributive property. Most of the time in your algebra class, this was called combining like terms. But here I'm going to call it distributive property. Let's take a look to part B. What property I'm going to use here to go from the first statement, which is 4x minus 5 equals 19, to the next one, 4x equals 24. So if in your mind say, hey, we go that by adding 5 on both sides, that's the way we do it in algebra, that's correct. Yeah, we cancel out this minus 5 and we have 4x equals 24. So this one, in fact, is the addition property. Addition property of the equality. I'm just going to write addition property. But again, one more time, distributive property of equality, addition property of equality. That's the complete name of the property. We're going to go to the next stage, and then I'm going to use this property we just mentioned and I showed you in the previous example to justify steps when we solve algebraic equation like this one. So we have here 2x plus 9 equals 19. So most in your algebra classes, you subtract 9 from both sides and you end up with 2x equals 10. Okay, so basically that's the property I use here, the subtraction property of equality. Subtraction property of equality. I'm going to write the short way like this. And then what else you did in your algebra class to solve? You divide by 2 and you get x equals 2. So this is what we call the division property of equality. So from this first equation we go here by subtraction property and then using the division property. Another similar problem with the other one, the only difference, and by the way, in algebra and geometry you can switch steps sometime. In this case, I personally add 4 to get x over 3 equals a plus 4 12, but that's not the only way to solve this algebraic equation. But again, in order to go from this step to this step, like I said, I add 4, so I use the addition property of the equality. And now if I want to solve for x, I need to get rid of these 3, so I'm going to multiply by 3 to get rid of these 3, so I'm going to get x equals 12 times 3, that is 36, to go from here to here. And that is the multiplication property of the equality. I'm going to write the short way like this. One more equation where we need to solve it and justify the steps. My first thing here will be to combine like terms in algebra, right? 3x plus 30 equals 180. If you remember, we call it here distributive property of the equality. Then my next step will be to subtract 30. So I'm going to have 3x here, because I get rid of the plus 30, equals 150. So this is the subtraction property. And one more step to find x will be to divide by 3. So we have x equals 150 divided by 3, that will be 50. And this will be the division property of the equality. Okay, so these are steps you can use in the justification for solving equation using the property of equality. And now we're going to move to the last stage that is very useful to write, to convince somebody about your work. It's called a proof, and a proof is a convincing argument that uses deductive reasoning. One way to do it is what we call two-column proof. On the left column you're going to put a statement, on the right column you're going to put the reason. So let's see an example. Write a two-column proof for each equation, and we have this equation which is given to us. So all the time when you're going to see a proof, something is given and you need to prove something. Okay, so we kind of know the answer in this case. We just need to do the proof. And how we do that, look at here, we're going to draw kind of a table, a two-column table. On the left side you're going to put statements, and on the right side reasons or justification, but we use reasons here. Okay, and you always start with what is given. Always start with what is given. 3x plus 8 equals 32. So this is my first statement, and this is, like I said, given. And now what will be the next step to solve and for x? Will be to subtract 8 to get rid of the plus 8, right? So we're going to have here 3x, because we eliminate 8, 32 minus 8, 24. And the property I used was subtraction. Subtraction property of the equality, if you remember. Now I need to do one more step to solve for x, which is divide by 3, right? 3x divided by 3 is x. And 24 divided by 3 is 8. And you notice this statement here, it's exactly what we need to prove. Okay, and what was the step we did? It was division. Division property of the equality. So again, do you see this deductive reason. Every single statement follows another statement. Logical connection between every single statement, and on the right side you see the reason. One more example here. We have this equation given, and we need to prove x equals 28. So the same two columns, and by now I think you know, on the left column we're gonna put statements, on the right side we're gonna put reasons. And always start with what is given. So we have 3x plus 40 plus 2x equals 180. Again, always the first reason will be given, and the first statement is what you start from. And you remember in algebra we said combine like terms, these two terms that have x in it. So we have 5x plus 40 equals 180. In algebraic proof we call this distributive property, if you remember. Distributive property of the equality. Okay, my next step to solve this equation will be to subtract 40. So we have only 5x here, and 180 minus 40, 140. And this will be the subtraction property. And the last step to solve this equation is divide by 5, and we get x equals 28, which again, if you notice, is right here what we need to prove. And the reason for doing what we did was the division property. Okay, so you have here two examples of writing algebraic proof for solving, in this case, were linear equation. Sometimes you just need to put the reason, you have the statement, or vice versa. Sometimes the reason are given and you need to write the statement, and sometimes you have a combination of this. Now, in this case, in this example, you notice we already have the statements. The first one is what is given. Now you should ask yourself, how do I go from this step to this step? And this is by by subtracting one. So here is going to be subtraction property of the equality. How do I go from this step to this step? Is by dividing by 5. So this is going to be division property of the equality. So, like I said, these problems are even easier because you really have to fill in the missing parts, in this case, the reason. Now let's move to the second part of the lesson, which is about geometric proof. So first of all, let's see some property of congruence, how we call them. They are corresponding to the one that we just mentioned, property of equalities. The first one, reflexive property. If you notice here, AB congruent to AB says AB congruent to itself, angle A congruent to angle A, angle A congruent to itself. This is called the reflexive property. The next property is called symmetric property. Let's see what this is about. If AB congruent to CD, then CD congruent to AB. This is symmetric property, and you notice we're using the segments here, but it's another one that works with angles. If angle A congruent to angle B, then angle B congruent to angle A. And the last one we have here, it's transitive property of congruence. Let's which says if AB congruent to CD and CD congruent to EF, you notice we have the same CD here, then AB needs to be congruent to VF. Those two segments are congruent. And similar we have for angles. And notice the same transitive property. If angle A congruent to angle B and angle B congruent to angle C, again you see they share the same angle B. There is no way angle A and C have to be congruent. That is what we call transitive property. Now let's practice a little bit these properties. You notice here we have two statements. the first one, measure of angle A equals the measure of angle S, and measure of angle S equals the measure of angle K. What property allows us to say that the measure of angle A is equal to the measure of angle K? If you notice, since we have these two guys, they are the same guy, that will be the transitive property. Transitive property of congruence. It's not wrong if you say equality, but it's transitive property of congruence. What about this one here? We have ST, the segment ST congruent with segment QR, and then the second statement segment QR congruent with ST. Do you notice? It's just flipped. We just flipped these two guys. This is what we call the symmetric property. Symmetric property of congruence. And the last one here, we have segment MN congruent with segment RS and segment RS congruent with segment GT. You notice again, these two guys, the same segment, in fact, RS. By transitive property, we can say the segment MN congruent with segment GT. Transitive property. Okay. Now let's put all these things together and write a two-column proof, a geometric two-column proof for this problem here. We have the measure of angle ACB, this one is X, and the measure of angle BCD, this one here, is 2x plus 13. Okay, also what we notice and is given to us, these angles form a linear pair. We need to prove that the measure of angle ACB is 50 degrees. So we're going to use a two-column proof. If you remember, the left column is statements and the right column is reasons. And you always start with, if you say what is given, then excellent. Angle ACB and angle BCD form a linear pair. And again, this is given to us. So now my next statement has to be a statement connect to the first one, which is this one. The measure of angle ACB plus the measure of angle BCD equals 180. What's the reason? Whenever you form a linear pair, the angles are supplementary. That is the definition of a linear pair. Okay, now we're going to go to a third statement, which is going to be nothing else than replacing these measures with the expression given. Measure of angle ACB is x, and the measure of angle BCD is 2x plus 30. So this is the substitution property of equality or congruence. In fact, the substitution property of equality here. Okay, and then you remember we have these two terms of x's. We combine them in algebra. 3x plus 30 equals 180. In geometry, I'm going to say distributive property. Then I'm going to subtract 30 on both sides to get just 3x. That will be the subtraction property of equality. And the last step to solve for x is x equals 50, where we do the division property of the equality. And we have one more step. Remember, you need to prove this guy. We need to go back and replace the x here with what we find out. Measure of angle ACB will be 50 degrees, and that will be substitution property. Okay, so you notice here we have a geometric proof, but some of the step here belongs to an algebraic proof, the last part. Sometimes you may have only geometric statements, like in this problem. You will see it, right? But also on this problem, I will suggest you sometime to do what is called an informal proof. Take a look. He says measure of angle BAC equals measure of angles DAE. Let's take a look. BAC and DAE. These two guys have the same measure. The angles are congruent, right? So if this is 20, this is 20, right? And then we need to prove that measure of angle BAD, which is this one, BAD. Let me change the color. These blue two arcs, this angle, and CAE, which is this angle, have the same measure. They are congruent, right? And if you take a look, we have this middle guy here. If this is 30 degrees, I think you can see it, then these angles are 50 degrees, right? 20 plus 30, 50, 20 plus 30, 50. So that is sometimes a way for me and for many others to look to a problem. What do I need to do? Okay, and at least mark on the picture what is given to you. That might help you. So now let's write the two-column proof. We kind of have an idea what we need to do. Statements. Reasons. And what do you think I'm going to start with? If you said what is given, then you are correct. The measure of angle BAC equals the measure of angle DAE, and that is given to us. Okay, these are the two red angles. I marked them on the picture. And if you remember, we have that middle angle, right? This guy right here. Look at here what I'm going to write. The measure of angle CAD, it's equal with itself. That is what we call the reflexive property, if you remember. Reflexive property of the congruence or the equality, because you have the equal sign. So now look at here what I'm going to do. My next thing will be to add the left side and the right side. So I'm going to have here the measure of angle BAC plus the measure of angle CAD equals with what? With the right side, right? The measure of angle DAE plus the measure of angle CAD. So this is nothing else than addition property of the equality. We have the equal sign here. But now let's take a look to this statement here. If you notice, this sum of the angles is the blue angle, how I call it at the beginning, this guy. That's my next statement. The measure of angle BAC plus the measure of angle CAD equals the big angle, which is measure of angles BAD. Okay, so what is the theorem, the postulate we can use here to justify this? It has a name. It's called angle addition postulate or protractor postulate. You can hear either way. But similar, we can use the same postulate for the bottom part of this bottom part. And we have here the measure of angles DAE plus the measure of angle CAD. Okay, we add the red one and this one arc, we get this angle, right, which is angle CAE, the measure of angle CAE. And again, this is angle addition postulate. Okay, so now we have to do one more thing, the last thing. We're gonna take this guy and replace it here. And I'm gonna take this guy and replace it this expression here. So what do we get if we replace them? We get measure of angles BAD equals the measure of angle CAE. What we need to prove. And this was the substitution property of the equality, since we have the equal sign. You notice this proof here contains a lot of geometrical statements and reason. Sometimes you just need to fill in either the reason or the statement or something mixed. In this case, in this example, we're gonna just need to fill the reason. I tend to think these problems are easier because you already have something. You just need to think, in this case, what's the reason. So what is the reason for angle 1 congruent with angle 3? Oh, you're right here, right? It's given. And you remember, you always start with what is given. But now let's take a look to this next statement. The next statement says angle 1 congruent with angle 6. I'm sorry, angle 3 congruent with angle 6. These two angles. Why these two angles are congruent? If you take a look here, we have what we call vertical angles. These angles are congruent. Of course, the other two are also congruent. Okay, vertical angles are always congruent. I'm gonna write the short way, just vertical angles, but the long way is vertical angles are congruent. And let's move to the next statement. Notice here we have angle 1 and congruent with angle 6. So in this moment, you want to take a look to the first statement, which says angle 1 congruent with angle 3, and the second statement. And you notice here we have the same angle 3, and then we have angle 1 congruent with angle 6. What property is the one that allows us to do this logic statement here? That will be the transitive property. Transitive property of congruence here, since we have the congruent sign involved. Well, now let's take a look to the next thing. The next thing we have here is says that angle 1 congruent with angle 4. Where do we get this guy? This statement, angle 1 congruent with angle 4. If you take a look, these two angles are also vertical angles, very similar with what we have here. So that's I'm going to put here. Vertical angles are congruent. I'm not going to write all that, but you should have that in your mind. Vertical angles are congruent. And now let's see. How do we get this last statement, which is what we need to prove? How do we get that? Again, you notice angle 1 congruent with angle 6, angle 1 congruent with angle 4. The same angle 1. So obviously these two guys needs to be congruent, right? So from these two statements we can get this one by using what is called again the transitive property. And that's it. So again, you notice the sequence of statements and the reason for those statements allows me to go from what is given to what we need to prove. Another way to do a proof is by doing what is called a flowchart or a flow proof. The statements are included in a box and the reason are below the box. And also we're going to use arrows to show the steps. So let's see, and we did this problem just a minute ago. We're just going to do now a flowchart. So if you remember, I said I'm going to start with what is given, angle 1 congruent with angle 3. We're going to put this statement in a box. And the reason for writing this statement is right there on the left is given. Okay. So now what will be the next thing? What have we done in the other slide, if you remember, or what was given in fact? It was given that angle 3 was congruent with angle 6. And I'm going to put that here. And what is the reason for these two angles to be congruent? If you remember, vertical angles are congruent. Now, there is no relationship between these two statements, so I'm not going to put any arrows. These two statements are independent statements. They have no connection. However, these two statements together will give us the next thing, right? Again, we notice angle 3, so obviously angle 1 congruent to angle 6. This is the logic statement that comes from these two previous statements. And what is the reason? Transitive property. That goes right here down. Okay, now I'm going to write another statement here, which is angle 1 congruent to angle 4. And if you remember, the reason for that one was that those two angles are vertical angles. Again, no connection between these two statements. Don't draw any arrows. However, now we can take a look, and these two statements together gives us the last thing, right? What I mean, you notice angle 1, obviously 6 and 4 needs to be congruent. Angle 6 has to be congruent with angle 4. No way, right? They are congruent with the same angle 1. And this is what we call the transitive property. So this is a flow chart or a flow proof that is very similar with the previous slide. We did it where we have a 2-column proof. I hope you enjoyed this video clip, this lesson. If you enjoyed it, don't forget to click the like button and come back on C-Square for more help. Thank you.